Welcome class. This is our last lecture on the Laplace transform series, and today we are going to do very important question, and it's a different type. In all these questions, what we were doing, we were having initial condition at y0 and y dash 0, but here we are not having so. So how we are going to solve this question? So this is particularly very important to solve. So we will take in such questions, like question reads as d squared plus 2d plus 1y is equal to t by using Laplace transform. Y of 0 is minus 3 and y of 1 is minus 1. So what we will do, that here we are not given y dash 0. So y dash 0 is not known. So I will take it as k. And once I am able to get my y of t, I will put y of 1 as minus 1 and I will find this constant k, and then I will get my answer. This is the procedure that we are going to follow. So first of all, you can write this Laplace transform as s square y of s minus s of y0 minus y dash 0 plus 2 times s of y of s minus y of 0 is equal to Laplace transform of t. Laplace transform of t is 1 by s square. Alright, now you can collect the coefficient, and we have forgotten about y, so we must be very careful. So when we take the Laplace transform of y, that becomes ys. So we can collect the coefficient of ys here, here and here. That becomes s square plus 2s plus 1 y of s. So what is y0? Y0 is minus 3. So minus minus becomes plus. So that becomes 3 of s. Alright. What is y dash 0? We are not given. So we are going to take it as a constant k. Then what is y0? Y0 is minus 3. So minus minus becomes plus. So that becomes what? 6. And finally we can write it as 1 by s square. So if we send all of these on that side, so we can write it as y of s is equal to k minus of 3s minus of 6, okay, plus 1 by s square, s plus 1 whole square. So we can see over here that we can write it as k, because this gives me in the partial fraction form. That is why I have written it like this, so that it can become easy to compute. We could have taken the LCM for all, and then that could also be done. We could have done. And here what it becomes, if we take s square as common till here, we get 1 minus 3 s cube minus s 6 s square. Okay, and we are sending this to the denominator, so that will be perfectly right to write in this fashion. All we have to now find is this using partial fraction. So I will write partial fraction for this. It can be written as 1 minus 3x cube minus 6 of s square divided by s square plus into s plus 1 whole square. We can decompose into, we can write it as a by s plus b by s square plus c by s plus 1 plus d by s plus 1 whole square. Now we can write this as 1 minus 3x cube minus 6s square is equal to a times, here we have to be careful, how much is to be multiplied? S. And what is left? S plus 1 whole square, b. For b, what is, we are already having s square, all we want is s plus 1 whole square. Here we are having only one of them, so we want one more, and here we have to take s square, not s. We have to be careful here. Plus d times how much? S square. So this is how we have been doing in all these questions. Here we should be very, careful. Now if I put s is equal to 0, what will I get? This becomes 0, this becomes 0. All that is left on LHS is 1, and here if I put here 0, so what becomes? B is our 0. Sorry, B is our 1. If we put S is equal to 1, we are putting here 1. So 1, not 1 because root is minus 1. So minus 1, 1 minus S minus 1 whole cube is how much? Minus 1. So minus minus become plus. And this become minus because S square, that is, they will make it positive. No negative sign. So we can put this as how much? We can put B as minus 1 whole square. So we get B as how much? 4 minus 6 is how much? Minus 2. So we got B and D. Now I will compare the coefficient of S to the power 3. Compare coefficient of S to the power 3. What is here on LHS? Minus 3. If we see here, if you open it up, S square into S, that is X cube, S cube. So we get here as 1. Here we don't have any cube, but here we have, that is S into S square. So that becomes A plus C. So this is an equation that we get. Now if we compare the coefficient of S square, compare coefficient of S square. What you will get? LHS minus of 6 is equal to how much? We are having here. We can see here. If you open it up, S square plus 2S. 2S into S is 2S square. So coefficient is 2A. Alright. Here, how much? S square only 1, so plus B. Here, S square into 1, S square, so plus C plus D. Okay. D also we are having S square. Now we can use this A plus C is equal to minus 3 in this equation. How we will use it? We can write this equation as minus 6 is equal to A plus C. A plus C plus A plus B plus D. If we put the value, this become minus 6 is equal to minus 3 plus A. What is the value of B? 1. What is the value of D? Minus 2. So we can see here minus 3 and minus 2, that becomes minus 5. Minus 5 plus 1 becomes 4. So if we take this as minus 4 outside is on the LHS, will get as A is equal to minus 2. Okay. So we have got the value A is equal to minus 2, B is equal to minus 1, D is equal to minus 2. And from this relationship, we can find the value of C as well. That is minus 3 minus A. So that is minus 3 plus 2. So that gives us minus, that gives us how much? Minus 1. A is how much? Minus 2. So if we send that side, it becomes minus 1. So we have got the values as minus 2, 1, minus 1 and minus 2. So we will just write over here, and we have to be also very careful about this one. We should not be leaving this because that is an other part. We have just found for these things. So I will just write now for this one. Over here only I will write K plus S plus 1 whole square plus, what is our A? A is minus 2 by S. What was our B? 1. What was our C? Minus 1. What is our D? Minus 2. So we have erased that constant part, but this is how it should be done. So you see here, this term and this term is same, so you can club it together, and we can write y of s as k minus 2 divided by s plus 1 whole square minus of 2s plus 1 by s square minus of this thing. Now we can invoke inverse Laplace transform. When we are doing it, what it will become? Y of t is equal to k minus 2. This is shifting, so e to the power minus t, and this is t, this is 2, this is Laplace inverse of 1 by s, and this one is t, this one is how much? E to the power minus t. So now we have to use this another initial condition, y1 is equal to minus 1. So we can write it as minus 1. Put your value as 1. So this become k minus 2 e to the power minus 1. This become 1. So this become minus 2 plus 1 minus e to the power 1. So we can see this become what? Minus 1. So minus 1 this side and this side, that will cancel. So what we get? K minus 2 e to the power minus 1 is equal to this thing. So we can compare the coefficient of e to the power minus 1 on both sides. What we get? K minus 2 is 1. So k is equal to 3. Alright. So we have got the value here. We can straight away plug here in this one. So this is 3. 3 minus 2 is 1. So we can write it as 1 by s plus 1 whole square minus 2 by s plus how much? 1 by s square minus, actually I have repeated it, I shouldn't have done that, I should just plug it here. K minus 2 is how much? Again 1. So I can write straight away as t minus 2 plus e to the power minus t minus of 1, if we are arranging it like this. So our answer is y of t is equal to t minus 2 plus e to the power minus t minus 1. So this solves our problem. So we can see very easily that only constants are changing. So these are the methods. So civil services mathematics is not merely about the initiative of going through the idea of having the techniques, but also various laborious methods, and that's what being tested. You are tested on different kind of methods, different type of questions, and that is all about it. So we have covered almost everything in this one. So now this is another question, which is the last question for this whole Laplace transform series. This question is asking that we have to solve the initial value problem using Laplace transform, that is d square y dt square plus ny 9y is equal to rt. Y of 0 is given as 0, y dash of 0 is given 4. So where we have to find what? Rt is equal to 8 times of sin t, and t is having 0 to pi. So and for t greater than pi, the value is 0. This question was asked in the recent years 2017 IAS for 17 marks. I have already told you in the previous lecture that this concept of second shifting property, we will be solving a differential equation for Laplace, and you can view that proof in the previous lectures. And that property that I talked about was this property: f of t minus a, u of t minus a is e to the power as fs. This property I have already proved. I have taken a question also which was asked in 2015, and this is the last question on this topic, and this is very important topic. So the focus area is, you can understand that, of UPSC is on different properties application. So I'll get started with this problem. We will invoke Laplace transform here. So what it will become? S square y of s minus s y0 minus y dash 0 plus 9 times of y of s is equal to Laplace transform of rt. So we have given the range. So what we can do, we can integrate it 0 to infinity. Okay. So we will be doing add. Before that it is divided into piecewise. So I can take it 0 to pi and pi to infinity. Here e to the power minus st, but here the value is 0. So this will be nullified. We will be not factoring this into, and for this we have 8 sin t e to the power minus st dt. All we have to do, we have to just do the integration. If you will recall our first lecture, I have given you a direct formula for e to the power ax sin bx is equal to e to the power ax divided by a square plus b square into a sin bx minus b cos bx. So we will be using that formula straight away. If you want to see the proof, you can do it by integration of part also. So this becomes s square plus 9x. We are just taking the coefficient of y(s). What is y0? y0 is 0. Y dash is how much? 4. So we have to just find out this integral. So what integral becomes? E to the power minus s of t. This becomes s square plus 1 minus a, so that becomes minus s sine t, okay, and minus of coefficient of sine, so that is minus cos t, and limit runs from 0 to pi. So here we can, what we can do is we can write this as e to the power, we can take this outside and we can write how much, e to the power minus of st. Here I am putting the upper limit, e to the power minus, in place of t I am going to write pi. So sin pi is 0, so this get cancelled. Minus cos pi is minus 1, so minus minus becomes 1. Minus of e to the power minus 0 is 1, so that will be 1. Sin 0 is 0, cos 0 is 1, so minus minus becomes again plus. So we have got the value. So with this we can write as 8 times s square plus 1 e to the power minus s pi plus 1, and we can write, we can take the minus 4 on this side, so this will become 4, and we can straight away write like this. If we take this denominator, in denominator it becomes s square plus 9 plus s square plus 9. Now our job is to finally decompose this and find the answer. So how we can write it? We can write it like 8 times s square plus 1 plus 8 times e to the power minus pi s divided by s square plus 9. Okay. Further we can write it as 8 times s square plus 1 can we do this like this? No, we cannot do it like this. This is in fraction, so that's a mistake over here. We can't write it like this. We can straight away write it as e to the power minus pi x s square plus 1 into s square plus 9 plus 8 times s square plus 1 into s square plus 9 plus 4 times s square plus 9. Okay, now we will decompose it, and we will be invariably using this property, so I will keep it here itself. If we write this as y of s as how much, we can use the shifting property. We can write it s square plus 1 minus 1 by s square plus 9. This is a shifted value. We can write it like this, e to the power minus pi of x. S square plus 9 minus s square plus 1. We can factor this into. Alright. So when we are factoring this, and similarly we can write for this part as well. This is s square plus 1 minus 1 by s square plus 9 plus 4 times s square plus 9. So this is a shifted value. So if we are going to invoke inverse Laplace transform, we can write y of t is equal to how much? This is shifted value. What is the value of this one? This is sine t, t minus pi. So we have to find this value and we have to multiply it with t minus pi. Minus of how much? See, this is not in the factored form. That is, you have to divide. So we can write 1 by 3 sine of how much? 3t minus pi u of p minus pi. Similarly for this one, what is it? It becomes plus 1 by sine t, and this is 4 minus 1 is 3. So this becomes 3 times of this one. So 3, this is the coefficient. So this becomes sine of 3t. What I am saying, this is 3. So 3 by s square plus 9, this is in the very much ordered form. So we can write this one in this format and we can write its value finally. So what we are getting is, we get it as, if we write this y of t, what we get? We get sine t plus sine 3t for 0t to pi. The moment we consider this one, what we get, its value is t minus pi is minus sine t. So it becomes minus sine t. This becomes sine 3t minus pi becomes minus becomes plus. So 1 by 3 sine 3t plus this value sine t plus sine 3t. So this one get cancelled. All that is left here is 4 by 3 sine t. So we can write it once more, 4 by 3 sine of 3t or t greater than pi, and we can copy the value sine t plus sine 3t 0 to t to pi. So this is our answer. This was asked for 17 marks. So you have to bear in mind that whatever question you have, if you are very thorough with your concept, this application, this derivation, at the same time lot of practicing, then your answer can be found out in very elegant manner. Thank you for watching. With this we end our series on Laplace transform. If you want to make us more videos, you can comment in the comment section, and we are going to take up in the next session ordinary differential equation right from the beginning. So thank you for watching once more, and please like, share and subscribe.